Hi, this is a quick demonstration to show you how to use the Debian Live CD. This is the screen that you will see when you start it up. The boot screen, immediately after the BIOS, would look like this. And for our purpose, we can start with Live or Live 686 because the emulated processor is 686 compatible. So we'll just go ahead and select Live 686 and press the enter key. That starts up the bootstrap process. It will take a little bit of time to get to the main screen, so let me just use this time to talk about the concept behind this. Right now, the emulator is using the CD image file as if it is a real CD. So if you put in the live CD into a system and boot from it, this is approximately what you will be seeing. And I am also plugging in two USB mass store devices. One is the USB mass store device that you will have your virtual machine that has already been installed to, and the other one is a quote-unquote blank USB mass store that we can use, as the quote-unquote live distribution. So there are two separate USB devices here. All right. So it starts up just fine, and ignore this message. When you see it, it's not important. It's missing one particular file, and it keeps complaining about it. But that's okay. We don't really exactly need that. All right. So right now we have the virtual machine started using the default user, which has a no password by default. It's something that we need to fix later on, but not right now. What we can do right now is to take a look at the hard drives, and we want to do some partitioning, restart the machine. You have a few options here. Let's see what would be the best way to do it. Let's do it this way. This is a little bit more troublesome. You have to do it every single time, but it is less troublesome from the perspective that you don't have to use another USB mass store device. So the choice is up to you whether you want to do it this way or not. The objective is we want to be able to start up the virtual machine, and from inside the Linux host environment that you get when you bootstrap the DVD from a hard drive, from your CD-ROM drive. Let us just go back and do it the hard way. The so-called hard way is actually easier in the long run, so let's go ahead and do it that way. And what I'll do is I'll go to settings and then go to gparted or gpartition editor. When you do this, you have to be really careful, because if you're not careful, you can nuke your the wrong drive in the system, and that would be bad. So now we have two drives here, and unfortunately they are both the same size, so it makes it really hard to find out which drive is which drive. The best way to do it is, since I have an extension 3 file system here, and the other one has a FAT32, this is how I can tell which drive is which drive, and also the label is different. This is our Windows compatible USB thumb drive, and the first one is the one that I'm going to erase. The first thing you want to do is to just remove the partition in the existing drive. So this is the drive that will lose all the content. So remember, you don't want to have any important data still stored onto the drive that you want to use for the live Linux distribution. So you got to make sure that really is the drive that you want to do, that you want to damage or destroy or reuse. So right now I'm going to remove this partition, and then I'll reallocate a new partition here. So right click on the empty space, say new, and we'll use an extension 3 partition. Everything else looks good except for the label. It has to be live -RW for read write. So this is a really important part, because the label is it has to be named live read write. And you click the add button here, and make sure that this is the right partition, because before you click this check sign here to actually apply the operations, you can still back out of this operation up to this point. And since I'm fairly sure that this is what I want to do, I click the checkbox or the check button here, and it checks with me one last time, and it goes ahead and perform the operation. So now we have a new partition created that is called live read write, and then the other one is SDB, and that's our DOS partition. It actually has a lot of useful content in it already, so we definitely don't want to accidentally remove that one. And then we can close gparted, and this is the first part. The first part is just to create a persistent drive, so that when we use a live distribution from the CD, we'll still be able to save our files to a USB external device as if the USB external device is a part of the file system to begin with. So this part is really cool, and we'll get out from here. Okay, so we have to reboot the machine in order for this to take into effect. Let's see. Yeah, I think we do have to go all the way out. I was thinking whether doing a init trick to change the run level would do the trick or not, and I'm pretty sure that's not going to do it. So let's go ahead and reboot the machine. Click the restart button, and the system will start to shut down. And for some reason inside QEMU it cannot reboot from inside itself, and I don't quite know why. Okay, it says no bootable device, even though the CD image is still specified there. So we'll go ahead and close this and then start it all over again. Okay, so I'm going to uncheck this. I just have to remember where I'm supposed to put it. Okay, there we go. And I'm going to restart the virtual machine and put it to the place where we can actually see the recording. I think it was off. Okay, there we go. And we specified live 686 again. And this time it will start up a little bit differently, because we have that USB master device that has one partition formatted to extension 3 with a label name of live-rw or read write. That tells the live Linux distribution that we should use that particular partition as our writable device. So when I save something to my regular user account, it will use that. So we'll wait until the system starts up and find out whether that's working or not. When it starts up, it will look almost exactly the same as last time. We have to run the command line command to find out whether the operation was successful or not. And I'll show you exactly what I'm looking for. Okay, so it starts up, seems to be exactly the same as last time. So we'll close. We start a command line prompt here, and we type mount. That tells me that everything is good this time, because let me highlight the portion that is important. This part here, because it is mounting SDA1, which is partition 1 of the first hard drive, as live cow. Cow stands for copy on write, which is the trick that it uses, when we write to a file system that seems to be read-only, because it's running from a DVD drive. It would actually copy the content that I'm writing to the USB device itself. But everything is done, seamlessly, so we can't really quite see it. So this is good. This means the system is already running, and whatever changes I make at this point will be saved onto the USB master device that has a partition that is labeled live-rw, which is exactly what we want to do. This interface, this GUI interface, is called XFCE4, which is a fairly minimalist type of file system. It is not like GNOME. It doesn't really support a lot of the cool automated, quote-unquote, automated feature here, which is okay, because it's, as I said, very minimalist. And if you look at top, you can find out how much RAM it really needs at this point. The system only has half a gig of RAM. And it seems like it's using a lot of the half a gig of RAM, but that's really not the case because of the 483 megabytes used, 243 megabytes are actual caches. In other words, the system is only using about 240 megabytes out of half a gig, which is fairly efficient. So it depends on how you want to do it. Since this is a Unix class, we might as well do it the proper way, the Unix way. So what we'll do is we'll mount the other drive. Okay, we have SDB as a drive, and we'll go ahead and mount that drive manually instead of using the system to do it. Maybe the system can do it too. Let's see. I don't really use the GUI too much, so I tend not to remember how to do it by this particular method. Alright, we'll just do it by hand. I mean, it's easy enough to do it. Okay, so we have to run the mount command to mount the other drive to a particular mount point. We only have to do it once, and so this is not a big deal. So it's fairly easy to do it using just the command line. Everything that we do, we have to start with sudo because it requires root privileges to do all this stuff here. So what we want to do is we have to make a directory first. So let's go ahead and make a directory in the media folder, and we'll just call that tmp1, temporary one, because we don't really need that after this, and we should delete it because everything that we create, the system will save for the next time. So we'll go ahead and do the mount here. Okay, this is the mount command. You have to first specify the hardware device, and in this case it is our SDB one. Now when you do this, you have to find out which drive is your USB drive that contains the entire folder of the virtual machine. So your SDB1, is not likely to be, your USB mass store is unlikely to be SDB1. So you have to kind of substitute that with whatever you use. And remember, you have to be very careful because all of these commands can potentially do a lot of damage to a file system. Okay, so we have specified the hardware device, and then we specified the mount point, which is the folder that we just created a little bit earlier. And if you do it like this and just press the enter key, well, I guess that will do it because the system will still be it'll still be readable to the end user, which is basically all we want. But on the other hand, you can also specify a bunch of options, which means you can specify the user ID of the subfile system or the new mount point to so that it is accessible to user. And you can also specify the GID to be user as well. So this way, the entire file system that we are going to mount in this command will be read-writable to the end user. And we press the enter key. We type the command mount again to double check and make sure. So right here you can see in the last entry, the block device is SDB1. It is mounted to the mount point of media/TMP1, and it is a FAT32 system. And it is read-writable to the user ID 1000, and the GID is 1002, which is basically the end user, the default user. And right now we can do a copy. So we go ahead and copy media temp1, and it has one single folder, which is our ciss342 VM folder. And we'll go ahead and copy that to the dot here, which is our current folder, the home folder of the end user. What we are doing here is we're copying an entire folder structure from either FAT32, or in your case it's probably NTFS file system, to the native Linux file system, which is extension 3, so that this way we can continue to use the live Linux distribution to run the virtual machine, so that we can set it up for the virtual switch and also the virtual network, because it's much harder to do it with Windows as a host operating system. So we'll go ahead and perform the copy operation, and it doesn't want to do it because it's a folder, so we have to specify -r. Okay, it's gonna take a while because remember everything is run inside a virtual machine at this point, which means the file operations are going to be a lot slower because it has a lot of overhead compared to actually using a hardware device. So we'll let it run for a while. And when you're inside the live distribution, you can actually go ahead and explore a little bit. For instance, we have all the usual stuff that we normally need. In other words, we have iceweasel, which is Firefox, which is great because you can do browsing and you can also access Moodle right away from inside a Linux environment, and that's really helpful. We also have PuTTY SSH client, which you already know, and a few other things that are actually quite useful too. Oh, the copying is all done. It took a little bit faster than I thought it would. Alright, so now we can go to ciss342 VM, which is the folder that we have created. And it has not copied everything that I need. It has copied the one thing that I really need though, so that's good. The one thing that I need the most is hd.img, the hard drive image file. But this is kind of strange because and it is the correct one. Okay, I'm going to copy everything else, from the host operating system, including the shell program to start it up. You don't really have to do this, because in your case you'll be copying everything correctly from the folder. But in this case, for some reason mine did not copy everything correctly. So I'll just go ahead and use this command to do it. 10, 2. Oh, okay. This is actually the host operating system's interface from the perspective of the virtual machine, but I think that's going to just make everything more confusing, so don't worry about what I'm doing here. And we want to copy everything with SH as an extension. Copy here. Maybe I got the IP address wrong. Yeah. Oh, okay. Yep, I did get it wrong. It is 10022, not 02. There we go. And enter the password. Okay, so now we have the shell command to start it up. Let's take a look at the shell command here. This is our shell command. It's using KVM instead of QEMU. That's because KVM is the name of the emulator in a Linux system. I specified the machine to start with 256 megabytes of RAM, which is probably going to be pushing it because that's a lot of RAM. Remember, the virtual machine, it only has 512 megabytes to begin with, so the nested virtual machine cannot really start with that much memory. I suspect 128 may be enough. Okay, so we'll go ahead and start with that. I don't need to start it up with the net install ISO anymore, so we'll erase the CD-ROM part. We'll start from the C drive, and I specify the rest should be okay. Okay, so we'll keep the rest the same for the time being and start it up. So we type /vm342.sh to start up the virtual machine. Now this is the really cool part that you don't have to deal with, but it's still cool to illustrate because what you're seeing right here is already inside a virtual machine. This is already inside a virtual machine. So what I'm doing here is to start up a virtual machine inside this virtual machine. If you watch Star Trek: The Next Generation, this is kind of like a holodeck within a holodeck, if you will, which is kind of an interesting concept. So if it starts up correctly, that's cool. And it looks like it's going to start up. My only concern is 128 megabytes of RAM sufficient to start up this particular version of Linux, and I guess we'll find out soon enough. It depends on how much stuff is installed, and a lot of that depends on which snapshot I am using from the live DVD. Okay, everything's looking good here. And of course I cannot remember my password. It's going to ask me again. Or maybe that's the correct password. Okay. Okay, it just took a long time. That was actually the right password, but it took a little bit of time to start up. Oops. I moved the virtual machine accidentally. Alright. Well, it looks like it's working. So that's good, because that means I have shown you how to set up your persistent drive in Linux and how to copy your virtual machine folder from your FAT32 or NTFS USB thumb drive to your Linux live persistent drive. So there are these two devices, and everything is starting up. It's just working really slowly because we are looking at a virtual machine inside a virtual machine. So the overhead is quite a bit. There's quite a bit of overhead to get this done. Now, when you are doing this, there's no need to change the amount of memory, because you'll be running the live distribution of Linux natively instead of inside a virtual machine that only has half a gig of memory. But this really, kind of shows you, how much stuff you can do with Linux, because of the efficiency of Linux. So right here we can start. Let's go ahead and log in. And I'm not sure whether that's the right password. Probably not. Yeah. So there we are inside the virtual machine. Inside the virtual machine here. And let's go ahead and see how much RAM is being used and how much spare do we have. Oh, that's really tight. Because right here it shows that we have 128 megabytes of RAM available, because that's all that I allocated to it. Oh, okay, it's not using much. Okay, I stand corrected. It was not using much. Of the 128 megabytes of RAM allocated, it's using 32 megabytes. Of the 32 megabytes used, only 16 megabytes are 16 of which are cache. So the system is really only using about 16 megabytes of RAM as it is right now, which I think is quite impressive. Okay, it is not running a whole lot of stuff right now. This is a fairly stock installation of Linux for our ciss342 class, but still, it is quite impressive that it does not use up that much memory when there's no GUI associated with it. So this is really good, because it shows that we can set up a virtual machine inside a Linux host environment. So for now, I'm just going to power off the nested virtual machine. Remember, this is the virtual machine inside the virtual machine. And that's because this is the other machine, so I'm already root. I can just power off. go. All right. So we are now back to the Linux host environment, and what I want to do is to shut down the command line here. Just exit, and we'll go ahead and I no wrong. Okay, I want to shut down the system. Okay, log out, and we'll perform a complete shutdown this time. And then when we start up the virtual machine again, this time I am not going to pretend that I have the FAT32 or NTFS USB thumb drive included, and just the one for Linux. So we'll go ahead and I'm just going to change the startup script here, and you cannot see anything because I'm changing the startup script, or if you want to see it, you can too. Let me see. Let me move this window over here so you can see it. So what I'm doing is I'm just starting up without the FAT32 partition. So I'm going to here and specify that we want to get rid of HDB, which is the second USB master device, which corresponded to the corresponded to the FAT32 or NTFS USB thumb drive. So we only have one USB thumb drive left, which is our live distribution persistent drive. Okay, that's the name of that thing. It's called a persistent drive. So let's go ahead and start the virtual machine again, which is your desktop running the live distribution. So position everything right so we can see it, and click on live 686. In other words, what I'm trying to emulate here is you unplugging your USB drive that corresponds to your Windows USB drive. And so we only have one USB drive left, which is the one that you just reformatted for the use of the live Linux distribution. And here we have the whole thing started again, and everything looks like it's the same as before, except when we log in using a command prompt, we can check the files and see whether files have been created or not. So we'll go in, start up a command line prompt here, do a ls, and you can see that we have ciss 342 VM already here. Unfortunately, there's no file. Oh, okay, that's because I forgot to press the enter key. And we have everything here, including the script to start it up. The rest of the files are fairly useless. In other words, you can delete all the other files except for hd.img and vm342.sh, because all the other files are a part of the QEMU distribution, but only for Windows. Inside this live Linux environment, we already have KVM installed, and that's why the other files in this folder are not really needed anymore. So from here on, we have a Linux host operating system, and at the same time we also have a Linux guest operating system, which I have not started here in this demonstration. But the cool part is we can now run Linux from a live DVD distribution and still be able to save files onto a USB master device. And as far as the end user is concerned, it is seamless. It will grab whatever it can from the CD-ROM drive or the CD-ROM media if there's one there. But if it is overwritten by a file that you saved earlier, then that file will be stored on the USB drive itself. And the system is merging the two file systems fairly seamlessly, so that to you it doesn't make any difference at all. Okay, so that really concludes the first part of what we have to do with the live Linux distribution, because with this we can set up the Linux host operating system to run Samba, and as a Samba server, and then we can set up the inside virtual machine to act as a client, or we can also use the GUI environment here to access a Samba implementation. And I guess we'll have another presentation to show you how to use the GUI environment to do that. Now, before we leave from this particular presentation, let me just kind of point out that the user really does not have a password to begin with, so there's no current password for the user, which is kind of difficult for certain things, because we want to be able to use GNOME instead of XFCE4 when we want to mount to a Samba server. So what we want to do is to say sudo password user, and this forces the system to create a password for the user, and it will ask me for the actual password for the end user. And since this is a live distribution, that, well, I suppose you should not be careless here. So we do want to have a fairly complicated password, and to make sure people cannot log in. The reason why I said that is because OpenSSH server is actually installed on the live distribution of Linux. So that means if you choose a password that is weak, other people can actually poke your system and find out that you have SSH already running. And if you choose a weak password, they can log in through your weak password. So that's why it is important to choose a stronger password in this case. And once I have specified the password, let me show you the other GUI environment. So we'll log out. This time, don't restart, don't shut down. Just click log out here, and it will restart the graphical user environment. But this time, it will also ask you to log in. Now, when you click Debian Live User, which is the default user in the live distribution of Linux, look at the bottom here. It allows you to select which desktop environment do you want to use. The system default is XFCE, but this time we want to switch to GNOME. Okay, so switch to GNOME here, and then over here you have to type the password that you entered earlier when we ran the command sudo passwd user, and then we log in again. This time it will take a little bit longer because GNOME is a kind of a bigger desktop environment, but it also gives you a lot of goodies, because it can mount to a remote file system more easily. And we'll just wait a little bit here. Uh-oh. Oh no, the system has locked up. Not entirely, it's just being very slow. There we go. It's not locked up, it's just being slow. Okay, so this is the GNOME desktop environment. You can see the interface looks almost exactly the same as XFCE4, except for one thing. Okay, if you look under Places, it can actually connect to a server using a GUI environment, and this is what we're going to do to practice, connecting to a Samba server, is to click Connect to Server, and under Connect to Server you can actually select a bunch of protocols, and here we can select Windows Share, and because I did not expose my host operating system here to share with my virtual machine, so it's not going to be able to find any server. But if you do have if you're working in a network that has Windows Share and that has Windows Share on one or more servers, you will be able to make connections to those particular servers. So we'll go ahead and play with this during the class. I have to first clear with Walter and make sure that we do have that you can use your student ID to log in using this interface. But other than that, we should be having a lot of fun today, because we can do all this stuff here. And that concludes my little demonstration of how to use the live distribution of Linux. Okay, so it's time to shut it down and stop the recording.